This week's topic is rocks. What are they and where did they come from? First of all, what is a rock? A rock is a group of minerals that are bound together. It's similar to how a cookie has ingredients. Well, rocks have minerals. The difference between minerals and rocks is that minerals are categorized by their chemical composition and their physical properties, such as luster and hardness and how they break. Rocks, on the other hand, are categorized by how they formed. One way to keep track of the forces that drive how rocks form is to think about Aristotle. In ancient Greece, people like Aristotle believed that there were only 4 elements: earth, wind, fire, and water. Today we know that's not true. Today we know there are about 90 naturally occurring elements, and fire, earth, wind, and water are not any of them. But his idea is still useful because it just so happens there are 4 forces that can change rocks. Pressure, which is kind of like earth; weather, which is kind of like wind; heat, which is kind of like fire; and water, which is water. And throughout this presentation, I'm going to use these 4 symbols to represent pressure, weather, heat, and water. There are 3 main categories of rocks. The first is igneous rocks, which are rocks that underwent so much heat that they actually melted and turned into a magma, and then they had to cool and turn into an igneous rock. Metamorphic rocks, which underwent an enormous amount of pressure and heat, enough that it changes the rock, but not so much to completely melt it. The third form of rock is a sedimentary rock, which undergoes a small amount of pressure, and it usually involves water. Either it's buried at the bottom of a lake, certainly transported by water, and weathering, which basically breaks a larger rock into smaller sediments. So the first rock we'll consider is an igneous rock. Basically, any type of rock can melt, and it can turn into magma. If magma cools and it solidifies, that is what we call an igneous rock. Now, igneous rocks are categorized in 2 main ways. The first category is the type of magma that the igneous rock came from. Igneous rocks can be felsic, which means that they are light-colored, low-density, acidic, rich in silicon and aluminum, and this is the type of rock that forms most of the continents, so these are like the land rocks, mostly. The second category is mafic. These are dark-colored, high-density, basic, rich in iron and magnesium rocks, and this is what most of the ocean floor is, are mafic rocks. Now, the second way that igneous rocks are categorized is where the magma was, the location of the magma. Extrusive igneous rocks formed from magma that cooled very quickly above ground. Crystals cannot typically be seen because they're too small, and textures sometimes look glassy or vesicular, which basically looks kind of like a sponge that has gas pockets. The other location is intrusive, and this is magma that cooled very slowly deep underground. It usually forms large intergrown crystals. So basically, on your reference table, you have a diagram that looks kind of like this. Everything above this red line are extrusive rocks that have very small crystal sizes. And everything below the red line are intrusive rocks that have larger crystal sizes. And then everything to the left of the blue line are lighter colored, lower density felsic rocks. And everything to the right of the blue line are higher density, darker colored mafic rocks. The other part of this diagram is down at the bottom. It lists all the minerals that can go into making into an igneous rock. Let's look at an example to see how this works. If you look at peridotite and you follow the dotted line down, you'll see that I've colored dark green for pyroxene and olive green for olivine, and you can see it varies. Peridotite can be anywhere from 50 to 100% olivine, and it can be anywhere from 0 to 50% pyroxene. The second category of rock are sedimentary rocks. The basic form is that any rock can undergo weathering, which is where it crumbles into smaller pieces, and then be eroded, which is when it's transported by ocean currents or a river or ice or wind. And those sediments can then be buried and then compacted and cemented into a sedimentary rock. The main way that sedimentary rocks are categorized is by the size of the sediment. Now, the first box here is clastic, and that's basically anything from the size of a boulder down to the size of a clay particle, and those are rocks that are basically just stuck together. If the particles are even smaller than clay, we call those dissolved particles, and that would be basically just dissolved in water. And if that water evaporates, you can get a crystalline rock. And then bioclastic could be any size. It could be as big as a boulder, although that's unlikely, and all the way down to dissolved particles. And those are any materials that are made from organic materials. On your reference table, the larger sediment is at the top of your reference table, and it gets smaller as you go down. They have a little bit of a different scheme for bioclastic rocks. They put those at the bottom, but remember, bioclastic rocks could be any size sediment. And here is the full scheme for sedimentary rocks identification, which is on page 7 of your reference table. The third type of rock is a metamorphic rock. Now, any kind of rock that undergoes enough heat and or pressure can become a metamorphic rock. The first way that metamorphic rocks are categorized is by the forces that changed them. So sometimes rocks undergo pressure and heat, and that typically forms foliated rocks, which means that all the minerals in the rock are aligned or banded. This typically happens over a large area, which we call regional metamorphism. And really, when you think about this category, think about mountains being formed. The other category is the heat-only category. And these are non-foliated, so we're not going to see any mineral alignment or banding in a non-foliated rock. And this usually forms over a small area, which we call contact metamorphism. And basically, this would form right next to an igneous rock. It forms next to magma. So this is rock that got really hot, but not so hot that it melted. The second way metamorphic rocks are categorized gets a little bit more complicated. The pressure and heat category is then categorized by the amount that they've changed. So what that means is that if you have a foliated rock, sometimes rocks are just a little bit foliated and they've only changed a little bit, and sometimes they've changed a lot. They've undergone an enormous amount of heat and pressure. The heat-only category is basically categorized by what kind of rock they used to be, which is the term for that is a parent rock. And so you can see on a simplified version of your reference table diagram, the foliated rocks are basically categorized by how much they changed. So we have increasing heat and pressure as you go down up until you get to that black line where you get to the non-foliated category, and then it really just lists what the rock used to be. And here we have the scheme for metamorphic rock identification. And lastly, make sure you're also familiar with the rock cycle and Earth's crust diagram on page 6. We've already gone through all these parts. There's just a lot more arrows, but if you're really careful in the way you follow the arrows from one stage to the next, it's not a terribly hard diagram. So if you have any questions, make sure you bring them to class.